Welcome back to Namaste Node.js Season 2 and we are building Dev Tinder. Now, in this episode, I am going to cover a very crucial important concept that how projects are built in the industry. We are not going to write code as of now in this episode. Don't worry, we will do it very soon. But in this episode, I will focus upon only how projects are built in the industry. I will tell you how exactly everything happens in the companies. You might have already seen that there is a huge gap between college students and what happens in the industry. When college students give interviews and come to the companies, they are unaware of what is happening inside the company. Right? They don't know what will happen once they are hired, how projects are built in the companies. It's a very different and a very new thing for a new fresher. But I want all my students, all the college students who are watching Namaste Node.js to already know exactly how projects are built in the companies. You will be industry ready after watching Namaste Node.js. A lot of people who are watching and who are already working in the companies would already know a lot of things which I will tell you in this video, but this video will be very crucial and groundbreaking for all the college students and the engineer who are waiting to join the companies or who are going as a fresher to any companies, right? It will be very groundbreaking for you all. I'm going to tell you the right way of building a project, how things are built inside the company. Okay. So people who are already working, who are senior folks, right? This video might be very basic for you all, but please trust me and please watch this video for the sake of students and for the sake of freshers who are watching Namaste Node.js. So you might not get a lot of knowledge from this video, but this video is very important for a certain segment of students who watch my videos. Okay, so let me start without wasting any time. Let me just move to the next slide and you might be already familiar with this diagram, right? All the computer science students who are the BTech computer science students had a subject software engineering in their curriculum, isn't it? In third year or fourth year or in second year, I don't know. Which year your subject would be, but there would be a software engineering subject and there you would have already heard about this model which is known as waterfall model, right? So we are going to revise this model and let me tell you in the industry, right? When we are learning in the bachelor's, right? When we are doing our graduation, we don't find the importance of all of it. But in the companies, this is a very, very, very important software development lifecycle method which is followed to build the projects. Now I will tell you the exact reality, what happens inside these big companies, how projects are built and how this model is followed. Exactly the same way. Suppose if Dev Tinder is built in a company, how will it be built? First of all, there will be requirement gathering. There will be requirements which will be defined that what is Dev Tinder, what features are you going to build, how you are going to build, what are the different scenarios, what will be the audience, what will be target audience, what will be the tech stack, and a lot of requirements about the product will be collected. And the job of collecting the requirements, right, is of the PM. And this PM is not the Prime Minister. This is the project manager, right? It is the project manager. There is a role in the company, project manager. People generally who do MBAs and then come into the companies, right? They are the project managers and their job is to define the product. It is not the developers who will decide what will happen in the Dev Tinder, right? No. Product managers decide what will happen inside. What are the requirements when you are building a project, right? Generally in big companies, either the project managers do it or in small startups, the company CEO does it, right? When you are a small startup of like 5-6 members, right? When a company is being built, so sometimes the CEO, sometimes the anyone, product engineer, somebody in the team would define the requirements, but the first step is to define the requirements. And generally in large companies, a product manager is the one who will define the requirements for you. Now, project manager also takes help of designers, right? Let me just write it down. Designers, right? So project managers, when giving the requirements, they also work with designers to create the UI mocks. Now a lot of students would see that, okay, if you want to build a form, you can't build it directly. Product managers will give you a design mock that, okay, product managers will work with designers and they will ask the designer to build a form. Suppose if you want to build a login form, so designer will build it, right? And then the designer will give it to product manager. The product manager will say, okay, do this, do that. It should look like this. It should look like that. And they will add it up in the requirements, right? Product managers along with designers, I would say a plus over here, they will work with designers and they will define the requirements. And in the requirements, you will already get the UI should look like this. There should be these features. There should be these functions. There should be a button to forgot password. There should be a feature to send the connection request and a lot of things, right? This is the first stage of requirement gathering. Product manager and designers will build the requirements properly. Now comes the design. Now this design is not exactly the UI design, right? This design is basically the, you don't exactly start writing code on the first go, right? Suppose you are starting to build a project. On the first day, you are not going to write any code, my dear friends. There will be a design document that will be created. Now, this is the responsibility of the tech team, right? Now the tech team comes into picture, right? The senior engineers, and the EMs, engineering managers. Senior engineer, the project, the tech leads, and the senior engineer, tech leads, engineering manager, they collectively make the design document. Design document means you are building the design of the application or the architecture, right? Defining the architecture, understanding and thinking about the tech stack, right? All of that happens in this phase. Deciding what tech stack will be used, what will be whether you are going to build a monolith or a microservice architecture, right? What kind of microservices are you going to build? What is the tech stack which will be defined? How will they communicate? And all these design happens. High level design, low level design, HLD, LLD, everything is built over here in the design phase. Hope you would have understood. Now let's move on to the third step. This is the place basically where the developers come into picture. And see, developers are also involved into these design discussions. Developers are also involved. But generally the SD1s, the junior developers, SD2, they are generally involved in this phase and a little bit in design phase. Okay. So I'm talking about big companies, right? I'm talking about big companies. So SD1, right? SD1, interns, SD2, right? All of them come over here in the development phase. Got it? Now comes the testing phase. This testing phase, sometimes, a lot of companies have a role SDET, right? Software Development Engineer Testing, right? These are testing team. These are the testers, or you call it as SDET role, right? So testers are there. They test your application. They write automation test cases. Sometimes they do manual testing, but it is the job of the testing team to test the application thoroughly. Plus, there is the job of SDs, the job of developers are also to write their unit test cases. And sometimes, writing test cases is part of development, right? When I tell this to college students, they feel that, what, Akshay, are you kidding me? Writing test cases is the part of development? Yes, my dear friends. As a developer, it is your responsibility to write test cases, right? Writing test cases, writing unit test cases is the developer's responsibility. But this testing phase is basically considered as the testing phase where testers are testing your application, or in some companies, there is no testing team, then developers do it, right? In a lot of big companies, let me take an example. In Uber, I don't know about other teams inside Uber, but the team which I used to work for, the finance team, we did not have a testing team. We were the developers, we were the testers. We used to write unit test cases, we used to write end-to-end test cases, right? And we were only testing our applications. But in some companies like Paytm, we had Inside Paytm, we had a separate testing team. They used to test the application. Got it? Now comes the deployment. Now you might have heard of a team which is known as DevOps engineer, right? So if your company has a DevOps engineering team, these DevOps engineer will take care of deployments. So generally DevOps engineer take care of the servers and managing servers and all that stuff. But deployment is basically done by developers only sometimes tester do it. It depends on how company is structured, right? But in some companies, even the DevOps team is responsible and involved into deployments, right? But I am just writing it that, okay, the role of DevOps team is to manage and take care of servers and all that stuff, right? So deployment is generally not exactly done by DevOps, but I would call this as developers. But you should understand that behind the scenes, DevOps team is the one who is managing the servers and everything, right? But deployment is the part of dev team only generally, right? You build a feature, and then once it is merged, once it is ready to live, then somebody from the dev team triggers the deployment. Not everybody has access to their deployment process, right? Only a few senior people can do it. Sometimes testing team also does it. Sometimes DevOps teams also does it, right? So it depends on company to company, right? And then the maintenance is like, maintenance means that you are following the same thing again. Suppose if you want to maintain it, and suppose if you want to build more new feature, then this whole life cycle follows again, right? So basically a new requirement will come from the product manager, then it will go to design phase, then it will go to development phase, then it will go to testing phase, then it will deploy, and then it will go live. Got it? So this is how companies work. Now you would have understood that, okay, product manager is making requirements, senior engineer and engineering manager are designing things up, right? The architects and the tech leads. Development is done by SD1, SD2. Testing team is doing testing. Deployment is done by sometimes developer, sometimes tester, sometimes engineer, sometimes manager. Depends on company to company. And maintenance is again a part of everything, right? Now this is the culture and this is the process in a very big company. But in a very small startup, what happens is sometimes just 2 or 3 engineers, they are doing everything, right? They are creating the requirement, they are defining, they are designing things up, they are developing it, they are testing it, they are deploying it, and they are maintaining it, right? So in startups, all these roles are not clearly defined because startups sometimes don't have a product manager, they don't have a designer, right? And let me tell you, in Namaste Dev, I am the product manager. I generally come up with the requirements. When you are watching this video, all of it was defined and the requirements were defined by me. I was the product manager. I was telling my team that, okay, it should look like this, it should feel like this, right? These are the requirements. You just should be able to do that, do this, and all of it, right? I was the product manager and I was part of the design team also, right? I was basically designing the high level design and the low level design, whether we should follow Monolith, whether we should follow Microservice. I was the one who was designing it, right? Along with my team. And the development, a little code I wrote, but a majority of the code is the team, the tech team which I have is writing it, right? So development was done by them, right? Testing is we don't have a testing team at Namaste Dev. The developers only test it. They write unit test cases and all of it. We do manual testing. We do all of it. So testing is done by us and deployment is also done by us. So what I'm telling you, in a very big company like Uber or Paytm or Google or Microsoft or FANG companies, there are separate people to do all of small things, right? But in small startups, a lot of things are done by the developers only. Okay, so got it? This is how these system, or this is how the software development life cycle works. And this model is known as waterfall model because it's kind of like a waterfall, right? You can assume it's a waterfall. I know it's a funny name, but that's how it is, right? So cool. So now let us talk about monolith vs microservice architecture, because this is very important. Because see, suppose if the requirements come to you, now you are designing the systems, you are thinking about how do you build a project, then you have to decide whether you are going to follow monolith architecture, microservices, what happens, what it is. These are the buzzwords for a lot of junior engineers, for a lot of college students. They don't know what it is and how things work, right? But let me tell you, what is a monolith, right? What is a monolith? So monolith means that you have a one big single project, right? That is why it is known as monolith, right? Monolith means one big single project. It does everything, right? It has backend, it has a database connection, right? DB connection, right? It has your front end, right? Front end code is also there. It has the code to authenticate. It has the code to send emails. It has the code for analytics, right? You write all the code in a single code repository, in a single project deployed on a single way, right? Think of it as a very big project. It has front end inside it. It has back end inside it. It has email service inside it. It has analytics service inside it. It has notification inside it. It has all the kind of things inside a same big project. A lot of companies follow monolith architecture. They have one big repository and a lot of developers are working on the same repository, right? That is what is a monolith architecture in a very easy way if I have to define it. What is microservice architecture? I'll tell you. Microservice architecture means there are multiple small services. Now, let me first of all tell you what is the meaning when I say service. What do you mean by a service? A service, a project, application, these are interchangeably used words. So whenever I say I'm creating a new service, I'm creating a new project, I'm creating a new application, it is one and the same thing. A lot of college students or junior engineers, they don't know about it. When we say in the high level design, right, that we will create a new service for sending notifications. We will create a new analytics service. So when I say service, I am talking about altogether a new project, altogether a new application, altogether a new microservice. Why do you call it microservice? Because it's a very small service and it has just one job, right? It does a small job. Example, there can be a microservice only for front end. There can be a microservice only for back end. There can be a microservice only for auth. There can be a microservice only for notification, right? There can be a microservice only for analytics. There can be a microservice only for admin or maybe only for creating dashboard, right? So basically in a large company, there are small projects, right? Handled by different teams and communicating with each other. Got it? This is microservice. Now, let me explain you everything, right? Once again, right? I know it can be confusing to a lot of new developers and a new college students, right? It is a big information to process, but think of it, right? One big project, you are doing everything inside it, right? And a lot of engineers are working on the same thing, right? The backend team is also working on the same team. Front end team is also working on the same team, same project, right? Same code base, big code base, right? I, in my career, my dear friends, have worked on Monolith also. I have worked on microservices also, right? So now in microservice architecture, you can build small applications. They are different projects. So front end can be a different project. Back end can be a different project, right? And there can be a separate team who is managing just the notifications, right? Let me tell you, in a very large company like Netflix or Uber, right? I used to work in Uber. So let me tell you about Uber. When you book an Uber ride, as soon as you request your ride, so there are so many microservices which gets active, right? There is a microservice which is just calculating the fare. Just fare calculation is a microservice. There is a altogether a different team which is just handling fare calculation. Suppose if you are booking a cab from point A to point B, so that microservices job is to just take those points, check the data, and they have their own algorithms and tell them that this will be the expected fare, right? If you book an Uber cab, so most of the time Uber pre-calculates the fare and tells you exactly that this will be the fare for your ride, isn't it? It does that, right? So there is a microservices which is handling it. There is a microservice which is just for fraud detection. There is altogether a different team which is managing a project which is just for fraud detection. There is a different team which is just handling the notifications. There is a different team which is just handling your invoices and billing. There is a different team, and these all teams are managing their own microservices, their own backend, their own front end, their own dashboards, a lot of things, right? So what I'm trying to say, when it's a very big company, they come onto these microservice architecture, but I know a lot of big companies also, they are using monolith architecture also, and they are very happy with that too. Right? So nothing is good, nothing is bad. These are ways of doing it. There has been pros and cons of monolith as well as microservices. But let me tell you, in the industry, there is a very big movement that companies are moving towards microservices. See, earlier, back in days, I think a decade before, all the application used to be monolith. But now, in new fashion, microservice architecture is followed in majority of new companies, in new startups, and it gives you a lot more flexibility. If you ask me personally, I like microservice architecture a lot, but I don't want to get into debate because there is a whole big debate in the tech industry about monolith vs microservices. I personally like microservices, and I will tell you the reason why, but it's a very big debate, right? Some senior people advocate monolith a lot, right? But that's a debate for some other day. My job as a teacher is to tell you my opinion and what is monolith and what is microservice. Let's move ahead, right? Now, let us just see. Now, I am not debating that monolith is good or microservices is good, but I will give you my opinion as a developer, because see, I have worked on monolith, I have worked on microservices. I will tell you on all these factors that what happens according to the dev speed in monolith and dev speed in microservices. I will tell you how is the code repo in monolith, how is the code repo in microservice, right? These are the parameters, and all these parameters I will discuss that what happens in monolith, what happens in microservice. Okay, it will give you a better idea about monolith and microservice architecture. Okay, let me just quickly go through them. I know this is again a lot of theory. Keep taking down notes, my dear friends. I know this season season 2 was supposed to be writing code, but we'll soon write code. But these things are also important, and this is very, very important for junior engineers plus a lot of college students who are going to work in the industry. This will be very helpful. For some senior engineers, you might find these information very redundant, but please go through it. It's a fun thing, right? Just hear on my opinions and what my experience is with monolith and microservices. Why not, right? I will share my experience. So whatever I am talking about these points, on the internet, you might find different opinions. So don't take my words seriously, but I will tell you my opinion when I was working in monolith, when I was working in microservices. Okay, because I have worked on both, right? So what happens to dev speed in monolith and microservices, right? When I talk about dev speed, so the development speed according to me is faster in microservices and slower in monolith. I'll tell you why. See, in monolith, and let me also talk about code repo. In monolith, there is a single code repository where all the developers are working. Suppose like 20, 30 developers are working on the single code repository, right? And in microservices, right, there are some developers working on one service, other developers working on one service, like a small group of developers are working on individual services, right? So what happens is single code repo, And in microservices, multiple code repos. So dev speed is slower in Monolith. Why? Because a lot of people are working on the same repository. Code reviews become slower, right? Sometimes, it becomes tough for execution also. When you take a very big project into your system and try to execute it, so the development speed becomes slow, right? And what happens? Suppose if you are running that application, you have to compile the whole project, work it. See, the more the code, the slower it will run, isn't it? So the dev speed is compromised a little when you are using Monolith. In microservices, it's very fast, right? In microservices, you can build it parallelly also. See, you can build parallelly in Monolith also, but in microservices, it becomes very easier that a front-end team is managing their own project, a back-end team is managing their own back-end, and they are building things up parallelly. In Monolith, sometimes it is difficult to maintain that combination. So dev speed, according to me, is faster in microservices, slower in Monolith. Okay. Now there can be a huge debate on this topic, but this is my experience. Okay. Now talking about scalability. When you are building a small project, when you are a small company, small project, so scalability is not a challenge in Monolith. But as soon as you are very big company like Uber, or not even Uber is a very, very big company, but even at a big scale, then it becomes very tough to scale Monolith architecture. Very tough. Why? Because your code repository is growing day by day. Every day there are so many lines of code which is being pushed. So maintaining that big repository is a mess. But suppose if you are creating small microservices, so it becomes easier to manage those small microservices and scale those services independently. So let me tell you an example. Suppose if you have a front-end microservice, there's a back-end microservice. So solving the challenges in that small project and scaling that repository is good, right? Scaling and monolith architecture is tough. It is very tedious thing, right? And architects spend a lot of time doing that and figuring out ways to do that, okay? So in microservices, suppose you have a analytics engine, and you want to scale that analytics engine, you can do it independently. Got it? So scalability is good in microservices, bad in Monolith. Deployment. Now, in Monolith, you just have to do a single deployment, your whole application is deployed. In microservice, you have to deploy each and every application separately. Right? Now, this can be a pro and this can be a con also. Let me tell you why. Suppose if you have to deploy suppose if you just have to deploy new feature on front end, right? Front end. Now in monolith architecture, you will have to deploy the whole project to just deploy front end. Suppose if you want to make a one-line change in your front end code. But it cannot happen unless the whole code is deployed onto the server, right? Deploying the whole code is a tedious task. It takes time and a lot of process and goes through testing and whatnot, right? Even if it's small change, one line change in the front end, still the whole testing process and everything is followed, right? So it becomes tough in monolith. But in microservice, suppose if you want to just make a one line change in front end, you can just deploy your front end application, front end microservice, and all the other microservice works in the same way. Right? So it's an advantage in microservice. But this can be a disadvantage also. See, when microservices are communicating with each other, if the backend microservice version is not aligned with the front end version, then there can be a mismatch, isn't it? Suppose the front end is talking to some other version of backend, then there can be a mismatch. Otherwise, if you don't worry about that, if the coordination is good, then it's not a problem. Right? And the development when it happens in microservices. So whenever there is a groundbreaking changes, so all the subscribers are already notified. So suppose if there are 5 front-end projects using some APIs, so you don't make any, so you always keep your APIs backward compatible. So what I am trying to say is there is a way of managing this deployment issues, right? Version mismatch issues in your microservice architecture, but it is good. If you have to ask my opinion, I would always prefer microservices because see, I have seen cases where you just have to make a small change and you can deploy it anytime because it's your microservice and you don't have to take a lot of permissions, and it becomes very easier for you to do continuous deployment. You can set up a CI/CD pipeline in your own separate projects. It becomes very easy in the microservice architecture. Cool. Now I think I am going a little slow. Let me go a little fast. Tech stack. In Monolith, you are restricted with the tech stack. Suppose in Monolith it's one code base. Now suppose if you are writing some front end, you can choose a React, right? Suppose if you chose React or you chose Angular, then you are sticking to it, right? Everything that you build, you stick to React and all, right? In microservice architecture, suppose if you are building a admin dashboard, you can build that in React. If you are building a student dashboard, you can build it on. So let me give you an example also. In namastedev.com, we have built the admin dashboard using React. The website that you use, namastedev.com, it is built on Next.js. Right? So it's a different tech stack because they are two different microservices. Got it? So in microservice architecture, you independently can use different different tech stack. Suppose if you want to build your analytics using Go, you can build that. Suppose if your backend is written in Java, you can build that, right? If it's a separate microservice. But in Monolith, if you are using Java stack, then you have to stick to Java for sending emails. You have to stick to Java for analytics dashboard. You have to stick to Java for everything backend, right? But in microservice, you are feel free to choose whatever tech stack you are choosing for different applications, right? That's how things are. But in generally, let me tell you, right? It's a good thing. In very big companies, generally you would see that some microservices are written in Java, some microservices are written in Node.js, some microservices are written in Python, some microservices are written in Golang, and it's a good thing, isn't it? Use the tech stack which is best suited for that particular microservice, right? That's why microservice architecture is good. Cool. Infra cost is a little lower in Monolith, tough in microservice, because see, the more the applications, the more the infra required. But see, infra basically depends on the traffic most of the times. But again, it's the way of how DevOps works. But in a nutshell, Monolith has a easier infra cost. It's like you deploy the single project on a server, right? How many servers you want to deploy. But in microservices, you have to manage the infra according to your microservices, right? So you need 3 servers for front end or 4 servers for back end, and that like you can customize it on your own, right? But that's how things are. But infra cost will be slightly higher in microservices because it's a separate microservice, need a separate server, separate teams, take their own servers and all that stuff, right? Even for testing also, suppose I am a developer, I want to test my particular microservice. So I will take a new staging environment or a pre-prod environment and do that, right? So infra cost is a little. Complexity, see, when you are building a very small project, then complexity is tough in microservices because see, you just have a small project. You are managing like 5 services for it. So it's tough in microservice. But as you grow, complexity increases in Monolith, single code base, so much code, so many files, folder, this, that. So it becomes a very messy, right? So complexity is tough for large project in Monolith. Complexity is easy in microservice when you are building a large application. Fault isolation. Suppose if one line of code in backend is faulty in Monolith, then the whole project breaks. Suppose if a small thing breaks in some piece of code in Monolith, so the whole project can crash. But in microservice, it just crashes only that microservice. Suppose if there is a breaking change, right? So only that microservice is affected. Actually, the whole system is affected, but then still that whole microservices will go down. Not everything will go down. For example, suppose if there is a issue in analytics, so only analytics service is going down. Not everything is going down, right? So fault isolation is there in microservice. In monolith, it is tough, right? Testing. Again, microservices can be tested independently, right? All the services can have their own test cases. In monolith, you write integration test cases for different things. But let me tell you my observation. Writing test cases in monolith was a little easier because you can write end-to-end test cases for the whole user flow. Because it's just one project, you can write the end-to-end test cases all throughout. But writing end-to-end test cases in microservices, the whole journey of user in microservices becomes very, very tough because these are different services. All these services are having different kind of APIs. So writing end-to-end test cases is tough in microservices. Okay. So here in testing, monolith is a little easier. Ownership, different teams take the ownership of different microservices. In monolith, there is a central ownership, right? And there are few people in the companies which decide that how will the deployment work and all that stuff. In microservices, there is a ownership of that small team who is managing that microservice. Okay, maintenance. It is easier to maintain microservices, right? And revamps also. Suppose in maintenance and revamp, suppose if you want to change the whole front end, right? So it is easier to change the microservice, right? You can just create a new microservices with a new front end, right? And you can revamp it. But it becomes tough to do the same thing in the monolith architecture. Debugging. Now debugging can be tough in monolith and can be tough in microservice also, because see, if something breaks, then you'll have to find out which microservices, what was it, which microservice is breaking it, and there can be blame games also. I have seen in the companies, suppose if something goes wrong, one team is blaming the other team. They are saying that your service is faulty. The other team is saying my service is faulty and my service is good, your service is faulty. So there can be a blame game, right? In monolith, debugging can be slightly easier because it's a whole one code repository. If it fails, it's easier to debug which file, which code, which where, right? It's easier, slightly easier. Now talking about the overall dev experience, my personal experience. I have worked with monolith, I've worked with microservice. I love microservice architecture, right? And I've tried to break my services down into smaller services so that they can independently scale, independently have their own deployment cycle, independently dev efforts and all that stuff. I like to do that way. Okay, so this is what my opinion on monolith and microservice was it, right? And I know it has taken a lot of time for you to understand this, but this is very, very important if you are building a project. And see, I can skip all of it and start building DevTinder. I can do that, but I am taking a lot of time, my dear friends, to teach you from the ground basics. If you are a college student, you should know all of it. When you will go to company, these things you will see. And you should know what is monolith, what is microservice and all. Otherwise, why I would be spending time in telling you all of it, right? I want to give you all the knowledge I can. Okay. So now let me tell you what happens in namastedev.com, right? Let me tell you, we don't have a lot of microservices, but we kind of follow a smaller microservice kind of an application. So let me tell you, there is one microservices which we call it as student web. So basically, this is the student web. This is the front-end application which you are using right now to watch these videos. Okay, this is the student web and it has its own tech stack. It is written in Next.js. Got it? We have a admin dashboard which is known as admin web. So it's a admin dashboard and it is written in React.js. We have another, these are separate microservice altogether. These are separate applications. Okay. Now we have a backend application, right? Backend application. This is written in Node.js. And this backend application talks to the admin, talks to the student web. Now we have these three microservices and we are also building one more microservice. which will be for the mobile application, right? Which will be for the student app, mobile app, right? Student mobile app. Okay, so for mobile app, and we will be using React Native to build this. Right? So what I'm trying to say, there are 4 microservices which we are using it. Now you can ask Akshay, you can ask me, Akshay, how do you send emails? So basically all the code of sending emails is written inside backend. All the analytics is written inside backend, right? But as our project will grow, we might split this backend microservice into smaller services for analytics, smaller services for sending notifications, but we are not very big of a company. So if we become very big, then we will slowly, when the company starts, they start with just 1 or 2 microservices, then they start building new microservices as the application grows and as the need grows, right? While you are watching this project, while you are watching these videos, right, we might have started planning to build new microservices in Namaste Dev, but right now we are just working with these 2 microservices, right? Why I am giving you all this knowledge? Just to give you an idea of how real world application works. Nobody will tell you all this. I am telling you what I follow in namastedev.com. I have also told you what I was following in Uber, I was following in Paytm, right? All of it, right? All this knowledge is practical based, right? These are my real world experiences. You are watching this video on namastedev.com. This project, Student Web, is the one written in Next.js. This code is loaded onto this website where you are watching these videos. That is talking to the backend. Right? That is talking to the backend. And this backend is written in Node.js. And we are going to build a similar kind of microservice architecture application. Got it? So let me just go ahead to the next slide and show you what are we going to build in DevTinder. I have told you Monolith, microservice. What are we going to build in DevTinder? Let me just tell you that we are going to build 2 microservices in DevTinder. We will keep it very, very simple. One is the front end and one is the back end, right? And these 2 microservices will be built independently, right? Will be built independently. Think about DevTinder was built in a company. So there would be a one front-end team who would be building the front end of DevTinder. There would be a back-end team who would be building the back end of DevTinder. But now, because I am alone building everything, I will build a front-end application and a back-end application, right? And these are 2 different microservices that we build. Front-end, we will keep it simple. We will use React. I will not be diving much into it. I will not be focusing much into making it very fancy and all of it. I'll try to do my best, okay? I am not just doing it for the sake of doing it. I want to build a very good project right now in front of you. And I will be using Node.js for writing the backend. Got it? So we will be building a front-end application or a front-end service or a front-end microservice or a front-end project, right? You can call it whatever you wish to. But we are going to build a front-end application using React and a back-end application, a back-end microservice, a back-end project using Node.js. This is what we are going to build in DevTinder. Hope you would have understood a lot of things. I want to take a pause over here in this video. But before that, okay, one more thing. Now, suppose if you build front-end separately, back-end separately, how does these 2 communicate? These 2 communicate using APIs, right? Backend will expose. Suppose if there is a front end, you load a page inside front end. Suppose if you load a profile page, right? If you load a profile page in the URL, you have devtinder.com, right? devtinder.com/profile, right? devtinder.com/profile. So what happens? It will make an API call to /get profile, and your backend will talk to the database, right? You have a database, and from the database it will get the profile and it will send the data to the UI, and the UI will show it onto the user's computer. Got it? That's how front end talks to backend, right? We have seen this in the previous season also, when I was discussing that when the user makes a API call, when the user loads a website onto the onto his system, what happens, right? You have seen all that, right? Hope you have not forgotten that, right? TCP/IP protocol, HTTP protocol. Remember all of it or not, right? That Node.js application. Now Node.js application talks to the operating system. Remember all of it or not, right? libuv, v8. Remember, right? Keep that in mind. That is the basic foundation knowledge that will still happen when we will be building this project. Okay, you don't have to forget that groundbreaking small basic knowledge fundamentals. Okay, that will be very, very helpful. Now we will be building all of it, right? I will show you how to build all of it in real time, how to communicate front end and back end, everything, right? And how to build independently back end, independently front end, and a lot of things you will learn while building this project. And I'm going to build exactly how it is built in the industry, right? So let's start diving into the Dev Tinder project. In the next video, this was all for this video. In the next video, I am going to start the software development life cycle. We will start discussing what is Dev Tinder, what are the requirements, what are the features that we are going to build. Then we will try to build the design, and then we will start developing the application. Okay, so that's how we will do in the further episodes. So slowly we will build it. I will be going slow. See, some of the students complain to me that Akshay, you are going very slow. You are teaching very slow, and it's kind of like boring. But see, trust me, you might be a senior engineer, you know a lot of things which I'm talking about, but there are so many students who watch and who are very new to backend, who are very new to Node.js, and this is going from zero to hero. So I have to start from zero, right? I have to start from basics. So if you know a lot of things, just be happy and feel that, okay, you already know a lot of things, but there are a lot of my students who don't know a lot of things. So I want to give them a lot of knowledge. College students are there, right? I want today's college student to be industry ready. I want to be a teacher where that is why, I have worked in the industry. What is the point if I can't tell my juniors and tell my students that what happens inside the industry, right? When I designed Namaste Node.js, I kept in mind that I want to give you all the industry level knowledge. Okay, so this is what I want to do, right? So let me not take a lot of time of yours, but let us just quickly revise. I talked about the software development lifecycle method. You understood all of it. Then I talked about Monolith vs microservices. You understood all of it. Then I talked about my experience and what happens in all of these cases inside Monolith and microservices. And then I talked about what happens in namastedev.com, all practical knowledge, what we use in production, right? And let me tell you, there are lakhs of students who are on our platform. There are 1 lakh plus students who are there on our platform, and we are running all of it using this kind of an architecture, right? I will talk more about Namaste Dev, how we built it, what microservices, how we wrote this code and all. I will talk as I build the project. I will keep taking examples from my experience in Namaste Dev, my experience in Uber, my experience in Paytm, my experience in previous startups. I will talk about everything from the practical standpoint. Cool. Then we talked about what we are going to build in Dev Tinder. We are not going to build a lot of microservices. We are going to stick to 2 microservices, and we will focus mainly upon this backend microservice. We will dive deep into this backend microservice written in Node.js. Okay, we'll write a lot of Node.js code to build a lot of APIs, and we will see how front end interacts with backend, and all of it. We will build a full stack project. It's not just a backend project; it's a full stack project that we are going to build. Hope you are excited for it. from the next video onwards, we will start talking more about DevTinder. This video was just about the important information about how we build projects. But now from the next video, we will talk a lot more about DevTinder, and I'm super excited to start building and start talking about DevTinder. Before I end this video, I have a small request. Please share a word about Namaste Node.js to all your friends, family, and on social media. Write a word about us. If you are liking what I am doing, what I am teaching, please share about it on social media. Maybe you can write a post about sharing your notes, or maybe sharing some knowledge, whatever I have taught in this video, summarize it and write a post on LinkedIn, write a post on Twitter, write a Twitter thread, share it on Instagram, write a blog on namastedev.com. You know that we have a write a blog section on namastedev.com. Write a blog. It will help you improve your knowledge, and it will help you spread your knowledge to your friends also, right? So please do that. Share your knowledge, right? And write about Namaste Node.js on social media, and don't forget to tag me, right? I would love to see you learning, and I would love to, whenever you tag me in the post, I just really enjoy it. It gives me immense happiness that you are learning, right? And please share about a lot of your knowledge on Discord. Help other people on Discord, okay? And grow your knowledge. Let us all grow together. And if you will share on social media about Namaste Node.js, that will help me reach to a lot of more students. And it's just a blessing for a teacher to be able to teach a lot of students. I need your help with that. Please share about us on social media if you are liking this series. And that's all in this video. See you in the next video. Let's just start building DevTinder, and I'm super excited. Okay, my dear friends, see you in the next video. Bye-bye. Take care.